Hey, okay. It says a few tricky items. Okay. Example 5 and 6. We'll do them together. On example 5, the very first thing on the notes on this fundamental theorem said something really important, and we may have glossed over it a little bit. I didn't mean to do that if we were in class. It's got to be continuous. So if the function is not continuous throughout the whole interval, you can't do it. And that's exactly the problem we've got right here. So on example 5, you would say, if you had to talk about it, the function 5x to the fourth minus 8x plus 2 over x is not continuous at x equals 0, which is on the interval we're talking about. So this is impossible. All right. So let's type that. Impossible. Due to the function not being continuous at x equals 0, which is on the interval. Or you could say it's not continuous on the interval brackets -3 to 6, something like that, and that would do it. All right, next one. I saw how Dean works this one out, and I'm not totally happy with that. I mean, it works, it's fine, but I think it's best to do this. Okay, absolute value is a weird one. We've not really had rules for that, so what you've got to do is just kind of remember what that thing looks like. All right, and absolute values always look like a V. All right, so and in this case, a V that zeroes out at 2.5, which is on the interval we're talking about here. So let's not do that. Let's do this. Okay, so I guess it looks something like this. All right, so at 2.5, so 1, 2, 3, 4 is where we're going. So at 2.5, it bottoms out right there, and it looks like that. Oh god. All right, pretend like that's good. Something like that. It can be a little bit higher over here than over here, since I didn't go quite as far. But anyway, whatever. Okay, so here's the thing then. So this 2x minus 5, when is it actually 2x minus 5? Well, it's over here. This part right here is the line 2x minus 5. All right? But absolute value involves opposites. So over here, on this side, it's negative 2x plus 5. And I know you're thinking, well, couldn't we just do triangles? Yeah. You could. You could do triangles. And if you had your calculator, you could just punch in your calculator, math 9. But if you, so how else are we going to have it? Well, if you knew how to draw it, then yeah, you could do the two triangles and yay, way to go. But if you didn't, you could do this. The integral from 0 to 2.5, because this is where this changes, to 2.5. There's been some arguments whether or not you need a parentheses here. I like to do it. It turns out that they will think of the integration symbol and the dx that you use as parentheses. Isn't that odd? So, but that always makes me a little nervous, so I don't do it. I go ahead and put it. All right, that, and then pick it up at 2.5. Go the rest of the way to 4. On this time, and this time it's going to be the 2x minus 5. But I'll show you something on the calculator real quick here. All right. Yeah. So that's interesting and everything, but let's break out the calculator and take just a little look at this thing here. We could have deal with the graph and all that stuff, but let's just say we want to. Let's move that. All right. I'm just going to math 9 the whole thing. So math 9. We're going from 0 to 4. And it's the absolute value. Absolute value is found in a couple places. I mean, the catalog is kind of cool because it's the very first one. It's in alphabetical order. So absolute value of 2x minus 5. Oh, yeah, 2x minus 5. Make sure all that's an absolute value. Come out there and tell us that we're dealing with x. I like the proper notation there. And there we go, 8.5. Now, and if you were to break it into two triangles, here's what the two triangles would be. So let's go math 9 again. Going from 0 to 2.5. The left-hand triangle would be the, come on, negative 2x plus 5. All right. And I know you could do this no problem, but I'm just showing. All right, so that's the 6.25. And then the other triangle is going to be math 9. And this one's just going from 2.5 to 4. So it's itty bitty. Good. And this one's a 2x minus 5. And this will be the rest of it. There you go, 2.25. And so together, of course, 8.5. But that kind of tells you. Now, if we had to do it by hand, which I don't know if there's a time where you'd have to, since without a calculator, you could do the triangles, and with a calculator, you could do math 9. So I don't know. But it's kind of cool to look at it, though.